Alright, so hi everyone. Today I'll be teaching on calculation for recurrences in algorithm. So I'll just teach the simple one, which is the linear and non-homogeneous one that is mostly in our question papers. I think so. Alright, so first of all, what I'm going to do is I'm going to explain what is going on, what is this kind of equation, and why do we need to understand it. If you want to do recurrences well, you need to understand it first. Okay, so we have Tn minus 3. So what is this supposed to mean? This is the recurrence part. Okay, this is the recurrence part. And then we also have plus 4. So this is the non-recurrence part. Okay, we have a recurrence and non-recurrence part. And then at the side over here, we have the base case. Okay, so what does this actually mean? Let me give you an analogy and let me tell you what does it do. Okay, so let's imagine I have like a flight of stairs, like banyak tangga lah. So this is Tn. Tn ikut lah level ke berapa. Contoh macam let's say dari level 9. Okay, and I want to go to T0. Let's say this is level 9 Okay, I want to go to T0, which is our base case. Our base case is T0, meaning once dah sampai 0, then dah sampai. There's no need for any energy or no need for whatever. Okay, hear me out. So next, what is the Tn minus 3? This is the amount of steps kita turun. Okay, amount of steps kita turun. So setiap round, I can turun 3 step. So minus 3, minus 3, minus 3. Okay, setiap round, I will go down 3 steps. Okay, then what is the plus 4 supposed to be? Okay, the plus 4 in this case, this is the amount of energy used. Okay, but in algorithm terms, it is the amount of work done. So after you minus the steps, you have to add the constant back. Sorry, the non-recurrence part back. Because in every round, you need to add it. It's like a constant. Okay, and you see why when we simplify the equation later. So keep in mind, in every round, you need to minus 3, and in every round, you need to plus 4. Okay, so we have two things going on. Alright, the T0 equals to 0 is nothing. That's not really important, but there is an indicator when the data reaches 0. Once we tolak 3, we minus 3 until we get 0, then it takes like 0 amount of steps to process the data, literally nothing. Okay, so how do I exactly solve this thing? Okay, let's solve it. Hold on. Okay, let me use a blue pen. Okay, so let's say I have... okay, so let's do about 3 rounds. So let's start from K1. Okay, K equals to 1. This is round, okay? How many rounds we're going? Okay, so for the first round, what I'm going to do is I'm going to write down the equation that we already have. Tn equals to Tn minus 3 bracket plus 4. This is the equation that we are already given. So imagine like at the top of the stairs, we have the equation with us. Okay, so Tn minus 3, this and plus 4. This is what's happening on the top. We're not moving yet. Okay, we're not moving yet. Okay, now let's go to the second round. K equals to 2. Now we are moving. Okay, now we are moving downwards here. Let me use a different pen. Now we are moving downwards. This is the second round. Okay, the second round. What's going to happen? Okay, so when I move down, what I'm going to do is I'm going to minus 3 steps, right? So let's put that. Tn equals to... okay, but what exactly minuses 3 steps? We are going to take this thing, n minus 3 plus 4 in a way. Okay, sorry. What exactly minus 3 and plus 4? It is this whole thing. Because we're going from the top here, we're going down. So you need to bring everything with us, okay? Alright, so what's going to happen is I'm going to write this, n minus 3. This is from the top here, okay? N minus 3. I'm going to minus 3 steps because I have to minus 3 steps, right? Okay, minus 3. Okay, then I'll write down the plus 4. The plus 4 comes from here. This is the plus 4. Okay, from the first round. Okay, then what's gonna happen next is I'm going to add 4. Okay, the constant that we have to add here, the non-recursive part, I have to add 4. Okay, so do you see what's going on? We have a pattern here where we have to minus 3 and plus 4 for every round. Okay, Okay, so the calculation here occurs here. Minus 3 plus 4. Minus 3 plus 4. So this is happening in the second round. Okay, so let's just solve what's happening here. And minus 6 plus 8. Okay, stay with me. Okay. Alright, so this is for k equals to 2. Okay, let's go to the third round. K equals to 3. What's going to happen? Okay, during the third round, what we're going to do is, let me take a different color. Okay, we are going to take Tn minus 6 plus 8 now. We are not going to take this one. We're not going to do this one. We're going to take Tn minus 6 plus 8 into the third round. Okay, because kita dah turun. Kita turun sampai sini dah. Dah sampai sini dah. We want to go downwards. Okay, so we take the equation that we already have with us. So what's going to happen, I'm going to put Tn over here. Okay, n minus 6. N minus 6, alright. So, dekat setiap round, what do I need to do? I have to minus 3. Exactly. So, that's minus 3 here. Okay, and then I have a plus 8 because earlier in my equation, I have plus 8. So, I'm going to put plus 8. And then, at every round, I have to plus 4. So, I have to plus 4. There you go. That is what you're supposed to calculate. Okay, so now let's calculate it. Let's solve it. N minus 9 plus 12. This is for the third round. Okay, so can you see the kind of pattern that we're having? Basically, what we're doing here, kenapa kita kena solve k equals to 3, k equals to 2? Because we are basically tracing what is happening. We want to determine siapa tolak apa, apa kena tambah apa. That is what we want to know. So, from here, we can already make a conclusion. We can already determine the general pattern. Okay, the next step is you have to determine the general pattern. How do you determine the general pattern exactly? Okay, like I said earlier, remember we have this non-recursive part which is a constant, right? Okay, so as you can see here, this one has only 1 4. This one has 2 of the 4s, which is equals to 8. This one has 3 of the 4s equals to 12. Okay, why is it 3? Because 4 plus 4 dapat 8 kan? Okay, plus another 4 dapat 12. Okay, that is what's happening. So, dari sini, we can conclude and we can make our general pattern. Okay, so what's going to happen is, I'm going to put Tn equals to Tn minus 3k. Why did I say 3k? Why did I say 3k? Because remember I said we have to minus 3 for every single round. And for every single round, as in 1, 2, 3. So if you notice, minus 3k, right? So what if I put minus 3 darab 2? I will get negative 6, which is this. Okay, that is what's happening. You need to find out what the pattern is and you have to determine what the general equation is. Okay, so that's why I am taking n minus 3k. Okay, and then like I said earlier, over here we have like a constant. Number 4 is our constant because 4 times whatever is 4 times the round that we're at is going to get the number that we have. Okay, so over here you can conclude that plus 4k. Okay, and in this case k is equal to round. How many rounds we are going? If I'm at round 2, okay, if I'm at round 2 and then I do negative 3 times 2, I get negative 6, which is the answer here. And if I'm at round 2, I do 2 times 4, I get 8, which is the answer here. Do you see what's going on? That is what's actually going on. Okay, so now that we already have our general equation, this is our general equation, what do we need to do next? Now, we need to reach the base case. How exactly do we reach the base case? So what I'm going to do is I'm going to do n minus 3k. I'm going to take only the recurrence part. I'm going to take only the recurrence part. I'm going to set it as 0. So n equals to, when we bring it over here, it's going to be positive. Okay, now we have to find k. Why do I have to find k? Because I want to find k. Why do I have to find k? I want to find k because I want to find the number of rounds that has to be divided by 3. Okay, so it's going to be n divided by 3. This is what's going to happen. Okay, stay with me, okay? I hope this doesn't make you confused. Stay with me. Okay, now what we're going to do is we're going to substitute this thing into this equation back. Okay, yes, it's so confusing. hold on, let me explain. Okay, let's substitute first. Tn equals to, okay, n tolak 3 n bahagi 3 plus 4 n bahagi 3. Okay, so when we solve this one we can just do this plus 4n over 3, right? Yeah, 4n over 3. Okay, so this one equals 0. So t is 0. This is the base case already. This is what we need. This is why I had to calculate k, because I want this part to become 0. I want to know what exactly, how many number of rounds do I need in order to reach our base case, which is t0. Okay? Okay, now we have 4n over 3. Okay, in this case, how do we determine the time complexity? I'm sure you've learned it in chapter 2 or something, where when we look at 4n bahagi 3, you just need to like pangkal, just cross out the numbers. Look at n. So in this case, we have only one n. So conclusion, our time complexity is on. Okay, so I know this is a lot to take in, so let's try another question. Okay, let's try another question, which is, let's do Tn equals to Tn minus 1 plus 10. Okay, and then the base case here is T0 equals to 0. Okay, so what's going to happen? Let's do 3 rounds also, because I'm too lazy to do too many rounds. Okay, so k equals to 1. What I'm going to do is I'm going to take the same equation. So I'm going to do Tn equals to Tn minus 1 plus 10. Okay, that is the first round. What about the second round? The second round, like I said earlier, what we're going to do is we're going to take this whole thing. Okay, and we're going to substitute it into here. This is why it is called a substitution method, because you are literally replacing the same value in every single round that you go. Okay, so I'm going to put Tn. So, n minus 1. Okay, before that, in every single round, I have to minus 1. And in every single round, I have to plus 1. So what's going to happen here? I'm going to minus 1 again. Okay, I'm going to minus 1 again. Oh, where did my pen go? I'm going to minus 1 again, and then I'm going to plus 10. Because this is what we have here. This is what we have here. Salin je benda sama. Okay, next. I need to add 10. Because in every round, I have to minus 1 and I have to add 10. Okay, now we can calculate what is actually going on. So Tn minus 2 plus 20. Okay, so this is the second round's equation. Tn minus 2 plus 20. Alright, now for the third round, how exactly do we do the third round? The third round actually, kalau korang tengok this pattern, n minus 1 plus 10, you can already congak apa jadi ni. So you can guess, the third round, kalau sini 10, sini 20, sini 1, sini negative 2, then obviously the third round is going to be Tn minus 3 plus 30. You see, this is why identifying patterns are so important. However, dalam exam, korang tak boleh shortcut lah. Tolong jangan shortcut, nanti tolak markah. So what we're going to do here is we're going to take the same thing. I'm going to take n minus 2 plus 20 and put it in here. So, n minus 2. Okay, in step down, what do I have to do? I have to minus 1. Okay, plus 20. And step down, what do I have to do? I have to plus 10. Okay, let's calculate that. Tn minus 3 plus t. And that is your equation for the third round. Okay, so now how do we identify the general pattern? Okay, so let's look at what's happening. Okay, okay, so let me change the color. Okay, so look at the rounds. We have round 1, round 2, and round 3. Let's look at round 2 lah kiranya. Okay, at round 2, so since we have negative 1, what darab negative 1 akan dapat ni? It's basically k. K darab negative 1. You're gonna get this. Why do I say this k? Contoh, k kita 2. Darab negative 1. Dia akan dapat negative 2. Which is this answer? Do you see what's going on? Yeah, this is what we want. So now I've already determined that the general equation could be something like this. Tn equals to n minus k. So there's no need for you to write minus 1 because it's literally negative k. It's actually when I take k equals to 3, right? Without negative 1, it is the same thing, negative 3. So just write negative k for this equation. Okay, now, what about the constant? What about the non-recurrence part? How do I determine it? It's simple. Do you see the pattern that's going on here? We have 10 over here, we have 20 over here, and we have 30 over here. When it's round 3, it will get 30. When it's round 2, we will get 20. So, the pattern here is literally 10k. Kenapa 10k? Because, contoh kalau kita dekat round 2, 10 darab 2, dapat 20. 10 darab 3, dapat 30. You see what is going on here? So this is the general equation of this thing. Okay, so now we've already determined the general equation. How do I find the base case? How do I reach the base case? So what we're going to do is we're going to do the same thing as earlier. We're going to take the recurrence part equals to 0. Okay, now we have to find k. So senang je, just terbalikkan benda ni. Dapat k equals to n. Okay, now I want to find the time complexity. I'm going to substitute this back into this equation. Okay, so what's going to happen? I'm going to do Tn equals to n minus n. Okay, plus 10n. Okay, so now let's just, oh, I forgot t. Okay, cancel that. Okay, we get 0 plus 10n. Okay, now how to determine time complexity? Cross the number and you get n. Therefore, your time complexity will be On. There you go. That is the answer. This kind of question is a bit complicated because of the patterns, but if you do more and more exercise on this, and if you are able to identify what kind of patterns that the question gives you, trust me, you're gonna do okay in the exam. So I hope this video helps you understand. I'm so sorry it's under 20 minutes. I hope you can skip whatever. And yeah, thank you for watching.